So today I'm going to discuss something about the matrices, and let's get started with discussing a little question. This is a 2020 level question, as many of you know that, and I'm sure that you have the question with you, so you can refer it while I'm doing the questions right here. So this is going to be an easy tutorial. I'm going to explain from the most basic to the most highest point of these matrices. So let's get started with the most basic thing. So they are asking you to prove that the left hand side is equal to the right hand side, and they have given you A, B and C as these matrices. So you can see that they are different in rows and columns. So let's get started with the very first question. So question 1 says that we have A transpose B minus I equals C. So this means A transpose. A transpose means that when you have A plus 1, 0, 1 and 1 and 0 and 1, what you got to do here is that you should consider taking A plus 1, first of all you got to take A plus 1, and then you should take this 0 right here, and 1 and 1, this the second row, and the third row comes like this. So this is going to be the transpose of A, the transpose of A. So if I made inside matrices are usually done in circle brackets and square brackets. That doesn't matter on what you put. What really matters is the final answer. So in now you have B, and now B is to be obtained normally. Let's take it with blue. 0, A, 0, 1 and 2. Now here they have given I. I is an identity matrix. An identity matrix only consists of ones and zeros. So this minus I is going to be an identity matrix of order 2. That means that when this matrix is considered, that 1, 0, 0, 1, this is the identity matrix of order 2. So you got to mention that 2 into 2, and in here you can see that there are 2 rows and 3 columns, 3 rows and 2 columns, and there you have it. So I'm not going to write C because I do not have space, but in the question, in the examination, that you should make sure that you write this C, and whenever you have LHS equals RHS questions, you always got to write both left hand side and the right hand side. I'm doing this because I do not have space. So in here, what we got to do next? Next, the property, the main reason we can multiply this. Why can we multiply and how can we multiply? First of all, we got to check the number of columns in the first matrix is equal to a number of rows in the second matrix. So in here we have 3, and in here we also have 3. So therefore the number of columns in the first matrix is equal to the number of rows in the second matrix. So in that state we can do this, multiply this matrix and say that the product of these two matrices will give you 2 rows and 2 columns. It will give you 2 rows and 2 columns. I'll actually do this a bit bigger. Two and 2. So now you got to multiply this. So this is how you multiply actually. The multiplication is really easy. There is only a basic fundamental that you should follow here. So A plus 1 will be multiplied by this. A plus 1 will be multiplied by this, and this one will be multiplied by this. This will be multiplied by this. I'll do that in another color so you can understand. In dotted lines. And in red color we have this. And in blue color I have this. So now we have A plus 1 and this and this and this and this. So the next thing what you got to keep doing here is that you got to keep multiplying this in this equation. So 0, 1 and 1. So a plus 1 into 1 will give you a plus 1, and 1 into 0 will give you 0. 0 plus 0 into a will give you 0. So a plus 1 plus 0 plus 0 is going to be a plus 1. So I'm going to write a plus 1 here. Next thing which we got to do is this one and this one. So you can see that I'm going to just circle these so that it's easy to see. So a plus 1 into 0 is 0. 1 into 1 is 1. 0 into 2 is 0. So therefore you have 1. 0 into 1 will give you 1 or 0. 0 into 1 will give you 0. Right? 0 into 1 will give you 0. 1 into 0 is 0. 1 into a is a. So therefore you have a right here. Next thing, this and this, 0 into 0 plus 1 into 1 plus 1 into 2 will give you 3. So now you have this matrix right here. You can subtract it with the identity matrix like this, and 2 into 2. And here you have this next thing which you got to do is in here in the basic rule so that you can add or subtract is that the orders of the two matrices should be equal to each other. If they are not equal, if the columns or the rows are slightly different from each other, even then you cannot subtract or add. To subtract or add a matrix, you should have the equal number of rows and columns in both the matrix. This base should be equal to the base of the other matrix in order to add or subtract. So a plus 1 and 1 will give you a, and this will give you 1. This and this is a, and this is 2. 2 into 2 minus okay, now that's so this is the final matrix that you get. So this is equals to C. So LHS equals RHS. So now we have proved the very first question that they have asked. So you will get about 10 or 10 marks or something for this. And let's get on with the next question. So next question focuses on something called the inverse matrix, right? The inverse matrix. So in here, they have said that show that C inverse exists if and only if A is not equal to 0. So if and only if A not equal to 0, C exists. Let's just find, we can show that it's that. So now if I take the matrix C inverse, now we have found that C inverse is this. So first of all, we got to find something called the modulus of C. C modulus is found like this. So now we can see here that we have two diagonals right here. We have two diagonals. This diagonal right here, this diagonal right here is called the major diagonal, while this other diagonal is called the minor diagonal. I'm not going to circle that because you can easily differentiate. So this is the major diagonal, the one you see here. This is the minor diagonal right here, right? In here, there is no minor major diagonals because you can see that this is not symmetric. In here, the major diagonal is this, and the other minor diagonal is here. So, taking the major diagonal into consideration, it is always a rule that you use the major diagonal. So, major diagonal says that it's 2 times A, and you got to subtract the major diagonal and multiplying the 2 elements or 3 elements from the major diagonal and subtracting them by multiplying the minor diagonal, right? So the minor diagonal is going to be A. So C equals A. Now they have said that show that C inverse exists only if and only if this A is not equal to 0. If this A equals to 0, this modulus does not exist. So therefore, if this is equal to 0, does not exist. So C inverse doesn't exist. And then you got to write the final statement that C inverse exists if and only if A not equal to 0. So from that statement you end this question. It's a very easy question that you can manage in your advanced levels, or if you're in ordinary levels, this will also be helpful for you. So if not, that you take that take A equals 1. Now we are going to do the real game. So what is C inverse? What is an inverse function? This is what we are going to find it. So C inverse is going to be, now we said that now we found that C modulus is equals to A. I'll write that result. If A equals 1, therefore C modulus is also equals to 1. And see, now we have C inverse, and now the major diagonal should be interchanged with each other, which is 2 should go to here and A should come here. So therefore 2 goes to here and A should come here, and here we have 1 and A. Therefore we have -1 and we have minus A right here. And not to forget that there is a C modulus. This modulus value we should multiply. 1, 2, minus 1, minus A. C inverse is going to be equal to 1 into anything is that number, right? So 2 minus 1 minus A and A. So that's the end of that question. So we have done that part as well. So we have discussed theory behind it. We got to interchange the major diagonal and we got to put the opposite sign to the minor diagonal. The opposite sign, right? We should not always make it minus. We should always make it plus. But we should replace it with the opposite sign it has. Because -1, positive A goes to -1 and minus A goes to positive A goes to negative A. It's easy like that. So in here, if we consider the last part, they say that find the matrix P such that CPC is equals to 2y plus C. So this is how we do it. So CPC, we have CPC. CPC is equals to 2i plus C, and now what we got to do here is that we cannot interchange, like we cannot put C here and put P here and say PC square. We can't do that. This is matrices. We cannot do that. If we do that, that will not be equal to the final result which we get. We should follow the steps which the question has given us. So we have CPC here. Now how do you actually find P? I said we cannot divide. So how do you actually find it? This is how we find it. So C should be multiplied. The first one should be multiplied by C inverse. And therefore we have C going to be equals to 2. About C inverse is going to be 2i plus C inverse is going to be this. So now you have C inverse C, P, C inverse 2i, and C inverse C. So therefore this C inverse C, anything multiplied by its inverse value, by its inverse matrix, will be equals to identity matrix. Will be equals to identity matrix of order 2, because the initial value was of order 2. So therefore this also should be equals to order 2. So this I write it as I dot P is equals to C inverse to I plus. In here also we can see that there comes identity matrix of order 2. Now here we have C right here. We have identity matrix here and the matrix P. Anything multiplied by identity matrix, we get that value. If we multiply the identity matrix with this matrix P, we will anyway get the matrix P. That is a special characteristic, a special property that you should know. Make sure you note those properties down in a paper or a notebook. So in here, now we can see that now the C still remains. There is one more C remaining here. So therefore, we got to multiply that also by a inverse matrix. P, C inverse is going to be C inverse 2I, C inverse plus I inverse C inverse, right? So now in here we can see that this is also going to be an identity matrix, NG multiplied by a. If we multiply P by identity matrix, we will get that specific P matrix again. So therefore, I'm just going to write P here. So now we have a clean expression for P. Now C inverse 2 C inverse plus C inverse. So here what I'm going to do now is that I'm going to multiply and do the relevant mathematical method. So C inverse is we have made a mistake here. So we got to replace this A. We got to replace this A by 1 because they have given it as 1. 1, 1, 1, 1, 1, 1. So because they have given A equals 1, we didn't take it, so now we took it. So I hope that was clear for you. So now we have C inverse, which is going to be 2 minus 1 minus 1, 1. This is going also to be minus 1 minus 1, 1. This is multiplied by a 2, and here we have C inverse again, which is 2 minus 1 minus 1 and 1. So now we got to do the normal multiplication. The multiplication can be done because here we have 2 into 2 into 2 into 2, whereas the number of rows and the number of columns in the first matrix is equal to number of rows in the second matrix. So therefore we have P here again, and the next thing 2 into 2 is 4, minus 1 into minus 1 is 1, positive 1, 2 times 2 plus 1 is 5, 2 and minus 1, 2 and minus 1 is minus 2, minus 1, and this is going to be minus 1. So minus 2 into minus 1 will be minus 3. So minus 1 and 2 will give you minus 2 plus 1 minus 1 will give you minus 3. Minus 1 into minus 1 is positive 1, 1 into 1 is positive 1. So therefore this is 2. Right? So now we have this. So next thing which we have is 2 right here. 2 minus 1 minus 1 and 1. So 5 into 2 will give you 10. This will be 12. Minus 3 into 2 will give you minus 6. Minus 6 minus 1 is minus 7. This will also be minus 7. And this will be 5. So this will be the final answer which you get for this question. So this question is a very manageable question. I'm sure you can do this in your paper, and if you have any doubts, you can always put it in the comment section down below, and I hope you learned something from this, and thank you for watching and have a nice time.